Hello, everyone. Welcome to the Microeconomic Theory 2 course post midterm break. Um, it's kind of strange organizing this class sort of online this way using screen records. Um, but given the extraordinary circumstances we find ourselves in, I hope we all sort of take it in the right spirit. I'm happy that I'm able to organize the class remotely. I'm trying to connect with you over this video temporarily, even though it feels strange now talking to myself in my room. But I hope I'll be able to convey and be able to explain the material through this mode. So it's a new experiment for me. I guess it's a new experiment for most of you as well. So let's see what happens. Um, just to sort of recap a little bit, so we have been discussing game theoretic concepts, and so far we have discussed a bunch of very basic but fundamental concepts in game theory. So, starting with the idea of dominated strategies, which are sort of ways to identify bad strategies in a game, and the concept of iterated elimination of dominated strategies, and then moving to the concept of best response, and then finally arriving at the concept of Nash equilibrium, um, where Nash equilibrium is defined as a set of strategies, one for each player, where each player is best responding to the strategies played by the other player. So if we find a set of strategies such that they are mutual best responses, then we call that a profile of strategies a Nash equilibrium, right? And we sort of made a distinction between pure strategy uh, and mixed strategy. Nash equilibria, where in pure strategy, Nash equilibria, we look for specific actions played by players with probability 1 as part of Nash equilibria, and in mixed strategies, we look for cases where players probabilistically pick one of the two actions or strategies. And these probabilities, we need to compute them so that they indeed constitute a Nash equilibrium. So the idea being that one player chooses a mixed strategy to make the opponent indifferent, right? Indifference was the sort of key concept behind identifying mixed strategy Nash equilibria. So the idea was that each of the player will be playing choosing these probabilities in a way such that it makes the opponent indifferent, so that the opponent can choose any mixed strategy equilibrium. Specifically, the opponent can choose the mixed strategy mixed strategy that makes the other player as well indifferent as well, right? So that's how we computed mixed strategy Nash equilibrium. So that's where we sort of stopped. In this class today, I wanted to go over some of the applications of Nash equilibrium, specifically pure strategy Nash equilibrium. If you remember, in the last class before we had the exam, we went over some of the applications of mixed strategy Nash equilibrium. Specifically, if you remember, we had this traffic police example where a biker is trying to choose a route and speed limit, where and the police is trying to choose which street to be present on, and we found a mixed strategy Nash equilibrium there. So we sort of went over some of those examples or applications of mixed strategy Nash equilibrium in that class. Today I wanted to discuss about 3 or 4 examples of pure strategy Nash equilibriums. These are applications of the game theoretic concept of Nash equilibrium in a sort of more realistic setting, let's say, and that would sort of help you get a sense of how widely applicable the concept of game theory is, right? Now, um, to begin with, we will think about the first application. So let's say, so today's discussion, just let me just write it down. Today's discussion is about applications of Nash equilibria. I'm sorry, the quality of handwriting is pretty bad because my stylus is not up to the mark. So please bear with me on that. So in the first application that we will talk about today, we will be talking about voting. Okay. So we can think about voting or elections as a game theoretic context or a strategic context. So think about elections as a strategic context. How it is a strategic context, you can think about in different ways. One way to think about it is that, say there are candidates who are or politicians who are running as candidates in elections, and they can promise to deliver certain policies, and depending on what policies they announce that they plan to deliver, voters can decide whom to vote for. Okay, so suppose voters have preferences, their utilities or payoffs defined over policies. So each voter likes to have certain policies implemented. Okay, but policies are like public goods. You can have only one policy in a sort of in a given region or in a given state or constituency, let's say. So, but different voters in the same constituency have different opinions or preferences over policies. And so, candidates have to decide what policy to announce, and depending on what policies different candidates announce, voters vote for one candidate over the other. And each candidate wants to win elections, so it's a so depending on what policies the opponent candidate announces, you may have different best responses, right? So your probability or likelihood of winning an election not just depends on the policy that you are announcing, but also the policies that that your opponent is announcing, right? So think about, say, in the current US elections, there are now primary elections going on in the Democratic Party, and so now currently there are two candidates who are sort of the leading candidates, let's say. One is this person named Joe Biden, and the other candidate is Bernie Sanders, and each of them are announcing certain policy platforms. So for example, Bernie Sanders, one of the policies is that to make public colleges tuition free. Okay, so that's one of the policies. Similarly, Joe Biden has different policies. Now, depending on these policies, voters will vote. Now, what policy that Biden will announce partly depends on not just his own preference, but also what Bernie Sanders is announcing, right? If Bernie Sanders changes his policy or would have announced a different set of policies, Joe Biden would have reacted differently by announcing maybe a different set of policies, because it matters where the opponent's policies are in terms of how many vote that opponent will get. So if you want to attract vote from the opponent's voters towards your side, you may have to react to what opponents is announcing by changing your own policy. Okay, so that's the, in that sense, it's a game theoretic context. So let's try to sort of formalize this idea. So let's say there are two candidates, okay, to keep things simple. So let's assume there are two candidates, call them A and B, okay, and let's say that both candidates care only about winning election. Okay, both candidates care only about winning election. I mean, you can have you can change this model, you can change this assumption, and you can say that candidates not only care about winning election, but they also care about the policies that they are implementing. So Bernie Sanders not only care about winning the presidential election, Bernie Sanders also personally cares about the policies that he wants to implement, right? So you can have a world where candidate caring about both. But we want to simplify this. Let's say in this model, candidates only care about winning the election. Okay, and the candidate getting more votes wins. Okay, so that's what it means to win an election, to get more votes than the other candidate. Okay, what about voters? So these are the candidates. Let me move to voters. So voters care about policies. Okay, what are policies? We denote policies by a number p which belongs to this interval -1 to 1. So think about voter policies, policies which is denoted on this line -1 to 1. Okay, so these are policies. One way to interpret this number as a policy is to think about, say, ideologies. Okay, so a number to the left means that ideology, the policy is more left in ideology, and numbers which are to the right are more right in ideology. So this is a right ideology, and this is left. So -1 is the leftmost ideology possible in terms of the characteristics of a policy. +1 is the most right-wing policy possible in the whole policy spectrum. Okay, and 0 is somewhere in the middle, so it's a centrist policy, let's say. So it's a right-wing ideology, and it's a left wing ideology. Okay, now voters have a favorite policy, okay, on this line mine between -1 and 1. So some voters are say 0, so they their favorite policy is 0, in the sense that they are centrist. Some voters are say zero point 0.2, so they are a little bit to the right wing, okay. Some voters are zero point 0.5, they are more right wing. Some voters are minus zero point 0.2, okay. So we identify voters with their favorite policies, okay, and each voter has a favorite policy, and that favorite policy lies between -1 and 1. So the more negative the favorite policy is of a voter, the more left wing is the ideology of the voter, and the more positive the number is the favorite policy is of a voter, the more right wing the ideology of the voter, right? And we have different voters with different favorite policies. So if you sort of stack the voters from left to right, you get a distribution of voters. So let's say there are lots and lots of voters, okay. So say the number of voters is very large, and so then if you find out their favorite policies, you will get a distribution of their favorite policies distributed over this interval -1 and 1. So let me sort of draw an arbitrary distribution. So let's say this is the distribution, okay, between -1 and 1. So this is the distribution of favorite policies of voters, okay. So now voters have these favorite policies, and that's the distribution of voters over the sort of policy space -1 to 1, and there are these two candidates who want to win elections, okay. That's the setup. Now what do candidates do? Let's move to the second part of the video to discuss about that.